on this, we have 3 separate examples of how to solve them. Okay, so we're looking at these linear equations. I'm going to jump around a little bit. Notice these are both equal to y.
Yep.
Notice this one's just equal to y.
Yep.
Notice this one, neither one's equal to y.
Yep.
Okay, our approach is different every single time. If they're both equal to y, we're doing one thing. If one is equal to y, we're doing something. If neither one of them, we're doing something completely different. You need to know this, okay? So make yourself a mental note of when we do this. All right? So y equals y, we're going to make them equal to each other. Okay? So I want burned in your brain every time you get to a question, a do now, or whatever. Maybe this is a good example. Right? They're equal to y, you're going to follow those steps. Are we clear?
Yes. Nah.
Okay. Who said no?
Me.
Okay, they're both equal to y, right?
Yes.
Are these 2 equal to y?
Yes.
Are they?
No.
No, only this one is. Neither one of these is equal to y, correct?
No.
Okay. So when they're equal to y, we're following these steps. Okay? So, first one, we're going to make these equal to each other. Okay, so I'm going to take 2x and I'm going to make it equal to x plus 5. 2x equals x plus 5. Are we clear? Equal to equal, we can make them equal to each other. It gets rid of the y's, we can solve for x. Okay? So we're going to do that. So looking at this equation, we need x's to one side and numbers to another. We have x's on this side, we have numbers on this side, so we're going to move this x over. Okay? So we're going to subtract x from both sides because we've got to do the inverse operation. 2x minus x is x. Does that look a little weird? No, because that's the way we write in algebra. Okay? In our brains, we like to see 1 there. If you need to write that in your notes, so be it. I'm okay with it. But understand, this is the way we write it. You're never going to see on the test or AZ merit 1x. Doesn't exist. Or 1y or anything like that. Okay? So x equals 5. Do we understand the first step of what we did? Or excuse me, the third step. First step is we just make them equal to each other. Okay? We're substituting one into the other. Okay? Equal to equal. Okay? Once we solve for that variable, we go back to the first equation and we plug it in. So we have 2x equals y. Okay? So if our x is 5, 5 times 2 is 10, we're done. 10 equals 10. So we have an ordered pair, right? We have an x, we have a y, we're done. Notice how this one's easier? Any questions on this? Okay. Now, are you with her? Okay. Ro, I got a spot for you right here. Minnie Padilla, hurry up, please. I want to get through the lecture. Okay. So equal to equal, follow those steps. Put them next to each other, solve for the variable. Once you solve for the variable, plug it back in. Okay? Let me see thumbs up or down. Okay, let me go through it one more time. Y equals y. We're making them equal to each other. Okay? So I got rid of the y's. I put 2x here, and I put x plus 5 on the side. Okay? Now from here, I need x's to one side. I need numbers to another. How I do it is I do the opposite operation. Okay? That's plus x. I subtract x. If I subtract x, what's there? What's left over?
5.
Right. Nothing, right? The x's solve themselves. Okay? So I do to one side, I do to the other. So 2x minus x is just x. Okay? Because there's an imaginary 1 in front of here. So 2 minus 1 is 1. But we don't write it as 1x, we just write it as x. Bring down what's left over to 5. So x equals 5. Are we good on this? Okay, second step. First equation, just go plug this in. So we're going to write the equation, draw a line. We're going to place the x with 5 because we solved. 5 times 2 is 10. This is a true statement. We're good. Okay? Yes? Are you stretching? Okay. So we have our x, we have our y. That's our last step, stating the ordered pair. Okay? Are we clear?
Yeah.
All right. This one's a little different. One of these isn't equal to y. Okay? So what we're going to do, we're going to pick this first equation that's equal to y, and we're going to substitute it in the second one for what it is. Let me explain. Y equals x minus 4, right?
Yeah.
So this y right here is going to become x minus 4. Are we clear? We took this equation for y and substituted it in here. Now notice, it's kind of the same thing here because we got rid of all y's, right? We replaced this y with this. There's no y in there. And so now we have x's. We can solve for x, can't we? Okay. From here, we're going to follow order of operations. All right? So we're going to write the inserted thing in parentheses. Okay? And then we're going to solve for this. First thing we're going to do is we're going to simplify. What's 2x minus 4x? 3x, right? And then we have bringing down our negative 4, bringing down our 5. Any questions so far? You sure?
Wouldn't it be negative 3x?
Thank you. Thank you. I meant to have my blue pen on me because I did that on purpose. Yes, you have to make sure that you simplify that it's proper, correct? So, what is my answer?
Negative.
Right? Okay, so let's talk about it for a minute. 3x minus 4, we want to simplify first, so any numbers you have, combine them, any x's you have, combine them, and then rewrite the problem. Then from here, we want to solve for x, so we're going to subtract 4 from both sides. 5 plus 4 is 9, bring down to negative 3x. Divide by negative 3, divide by negative 3. 9 divided by negative 3 is negative 3, right? Positive by a negative. So our ordered pair is negative 3, negative 1. Once we know what this x is, we're going to go back into the equation that we substitute and solve for it. Okay? So we're 3 minus 4, which is minus 1. We're done. We have our y, we have our x. Any questions? Yes? Why is it negative? Oh, because, come, quickly, I'm recording. Come around this way, come sit right here. Okay, Cameron, because we have 2x and x, right? This is a plus. If we were to multiply this out, it would be the same, right? It would just be x and then minus 4. Okay, so x and x, actually no, it is 3x. It's not minus 3x. Because we don't have distributive property here. But if there was a negative here, we would have had distributive property. So actually it was okay. Yeah, I know. I want to go through it again.
Yeah. You just lost me completely.
No problem. 2x, nothing happens in here, right? We do have distributive property here to take care of this symbol, but nothing's going to change here because this is plus times x, which would just be x by itself, and then plus times the minus, which would be minus 4, so there's no change. But if this were a minus, and I'm going to rewrite this, if this were a minus, that would change, right? Because we have an imaginary negative 1 in front here, we'd turn this negative and we'll turn that one positive, depending on the symbol, when we put it in parentheses, right? So this plus isn't going to matter. What's 2x plus 1? Minus 4, minus 5, or excuse me, plus 5. We're going to add 4 to both sides. 9, bring down to 3x, divide by 3. Once you have the x, substitute it in the very equation that you substituted, okay? By the way, it really doesn't matter. You could put it in either one. But you want to pick the easier one. Any questions with this? Y equal to each other. Y equal to itself, substituted in the second problem. Okay? Notice, 2 different ways to solve the problems, right? Okay.
So when you
Yes.
substitute it, you take away the y from.
Yeah, because what we're saying essentially is we're saying this is equal to this, okay? So we're taking this y, we're getting rid of it, and this information is going in here. That's what I did right there. That's why I wrote it in red, okay?
Yeah.
And you want to put it in parentheses. Really, the main reason why you want to put it in parentheses, depending on what this operation is right here, okay? Now, in this case, it didn't change, but if it was negative, it would have changed. We would have had to do distributive property. Okay? And once again, all we're trying to do is figure out our ordered pairs. So we're taking information, we're substituting in to isolate and get a variable by itself to be able to solve for the other one. Okay? Y to y equal to y. Two different ways. Okay, last step. Nothing really new on this. Nothing's equal to y, right? When you do not have an equation equal to y, you're going to pick the equation. I'm about ready to throw something at you. You're going to pick the equation that's easiest to solve, okay? So looking at this one and looking at this one, x and y are by themselves, right? So we're going to pick this equation and we're going to get x by itself. All we have to do is subtract 4y from both sides. Are we clear? Okay, we just solved for x, right? So that means we can take this and we can plug it into the other equation to solve for it. So x becomes 6 minus 4. So I'm putting 6 minus 4 where the x used to be and substituting it. Notice I don't have any x's here. Right?
Why did that turn into minus?
The minus 4y?
Yeah.
Because what's this right here? This is plus, good question. This is plus, minus 4y on the other side, just bring down the 6. Notice we don't have an x here, so it really doesn't matter the way we put this. We could have wrote it minus 4y plus 6, but actually writing it 6 minus 4y is just one operation you're not having to write. But it really doesn't matter. Okay? So taking the information, putting it here, we're going to solve. Well, we have 4y and we have y, right? So negative 3y, right, Naomi? Because we're negative 4 plus 1, so we're 3. Bring down the 6, bring down the 3. Okay? Now we need the y's by itself. We're going to subtract 6 from both sides. Negative 6 minus 3, negative 3. Divide this by negative 3, we get y equals negative 1. So the only thing that's different in this one, pick the equation that's easiest to get a variable by itself. Okay? Plug it into the other one to isolate, get your variable, and then go plug it back into the equation. Okay? So when I say plug back into the equation, never change this. Leave it the way it is. You're not putting it in slope form. There's only time you're not putting it in slope form. Okay? Because are we graphing here?
No.
We're not. So it doesn't matter. Okay, last step, we solved what y is. So we're going to rewrite the problem. We're going to go replace y with 1 and solve. So 4 times 1 is 4. Bring down the 6. Subtract 4 from both sides. 6 minus 4 is 2. X equals 2. Okay? 3 different ways. Tell me, what happens when it's y equals y? What are you doing to solve? This is where you guys want to answer this. We covered it.
Y equals y.
Yeah, when you have two equations, y equals y, in other words, y are equal to themselves, how do you solve it?
Well,
X and substitution.
Okay, and how do you substitute it?
Use one of the equation.
Yeah, I'll take that. You're making both equations equal to themselves, okay? By making y equal to y, you just got rid of the y, so you were able to solve for x. Okay? You solve for x, you plug it back into the equation, you're able to figure out your ordered pair. What about when one's equal to y, but the other one's not? Same word. What happens if I'm not here? Yeah, substitute it in. Okay? That's going to substitute it in. You're going to be able to get your variable by itself. Go plug it in the other equation. You notice this one's easier than what we just did? If neither one of them is, this is where you have to be creative. Creative from a standpoint, you got to look at the equation and decide what's the easiest thing to do. Now, look at this one. I could have taken this one and I could have subtracted 4y to both sides, right? But I chose this one because it was a simpler equation. Easier to insert, easier to solve. Okay? We could have picked this one. As long as you follow all the right steps, you'll be fine. Okay? Keeping the problem balanced, what you do to one side, you do to another. Any questions? Okay. So let's talk about the do now. You have 4 questions, right? This one is just like example 1, right? It's y equals to y. What about this one? What example is this one like?
C.
Okay. What about this one right here? Okay. What about this one right here?
oh, no.
Good. Okay. Get your do now done. Make sure that you have your notes done. You don't have any vocabulary in this section. Okay? So, get this part done. Use your examples to finish your questions. All right? Make miracles happen. Let me see that pencil move. Okay.